Hey, Mr. Simon here. I hope you're doing well. Now that we're getting ready for the create task, I want to go over functions, algorithms, and abstractions because these are all things that you're going to want to talk about when you're writing about your create task. So what is a function? Well, I think of functions like paragraphs. So when you're writing a paper, you don't just go sentence, 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 sentence. You divide those sentences up into blocks or chunks that we call paragraphs. And every paragraph has one topic. And all the sentences in that paragraph address that topic. Well, it's the same in programming. So when we're writing code, we could just write code, 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 but it's a lot easier if we organize it so all the code that works on a particular part of the program is put in the same place. And we call that a function. So a function is like a paragraph. It's a collection of code that does some particular job or focuses on a particular problem. So here's an example. Here's my smiley face program. Right now I've just got the standard functions set up in draw. I'm going to break this down into some more functions in a little bit. But we know that every P5 program has at least two functions, setup and draw. Now, we'll get to this in a little bit. Now, I want to point out some symmetry here in my smiley face. I've got two eyes. My face is centered at 50-50. So if I want to make those eyes symmetric, if I add and subtract the same amount from that 50 and X, subtracting will give me a position for the left eye, and adding will give me a position for the right eye. And I've got symmetry in the smile here too. Pi over 2 is right here in the middle. This is 0 because we're upside down in programming compared to math class. So if I go pi over 2 and I add, I'm going to get further away from 0, and that's going to make this part of the face. And if I subtract, that's going to be this part right here. So I'm going to make the smile from minus 0.9 all the way up to plus 0.9 on either side of pi over 2. Now, modern programs are huge. Millions and millions of lines of code that are the product of teams of programmers all working together. And this only works because of functions. You can't have one person write a million lines of code and even remember the first thing about it. So we break up the program into parts, and different programmers concentrate on those different functions. Now, we've seen that every P5 program has a setup and a draw. So let's talk a little bit about what those two things do. So you put the stuff that you want to happen at the beginning, and it only once in setup. And then code that draws shapes or animates would go inside the draw function. And that draw function repeats automatically by default 60 times a second. But we can put in as many additional functions as we want. Functions are written with the word function, followed by a name, then a set of parentheses. Parentheses uniquely identify functions in JavaScript. And then we have curly braces. And those curly braces are what marks the beginning and the end of that block of code. Just like the way indentation and a blank line marks the beginning and the end of a paragraph. So this is the beginning of the code for my setup function, and this marks the end down here. And then any code that I put inside those curly braces is going to be indented. So for setup, we do things like we create the drawing canvas. If we have just one background color that we want there to be once at the beginning, we might do that. If we're going to be using the same stroke and fill for the entire program, we might put that in setup. In draw, however, we might put background there if we want to repeatedly draw the background or draw the background in different colors at different times. Same if we want to set the stroke and the fill to different colors at different times, we'd probably put that in draw instead of setup. And then all our other drawing functions like ellipse and line and rectangle would be called from the drawing function as well. Here I'm going to break it up a little bit more though. Here's my smiley face function, and now I've broken out the code that makes the yellow head into its own head function, and the code that draws the black features of the face, the arc for the smile, and then two black filled ellipses for the eyes. I've put that in the face function. Now, writing these functions doesn't make that appear on the screen, right? Remember, draw is what does all the drawing. So I call the head function and then the face function from the draw function, and that's what gets it to show up on the screen. Now watch out. Do you know what I messed up on here? Take a look. Let's go back. Here's my working smiley face function, and here's one where it's missing the face. Look at my draw function, right? Order makes a difference. That head is a big yellow ellipse. If I call the head function after the face function, that big yellow ellipse is going to cover up the face. So we want to pay attention to order. The order that we use the functions, the order that we call them is what's important, not the order that we define them where we write out how they work. It's when we say when they work with these function calls that order is important. So functions are an example of abstraction. You know, a good way to think of abstraction is when we use a single word to describe something that's actually pretty complicated. Like look down here at face. When I'm drawing my face, I'm doing some math here to get this arc for the mouth, and then a little bit more math here to draw the two eyes. But I'm just going to think of it as the face. When I say face, it's going to draw the face. So that's a simplification. That's an abstraction is a way we try and reduce or manage complexity in our program so we can keep our eye on the big picture and not get overwhelmed with details. Now, functions are reusable. That's a really neat thing about them. We can keep calling the ellipse function as much as we want. So how come if I call head and face twice, I don't see two heads and two faces? Well, the problem is where I'm drawing them. Since all of the ellipses are centered at 50-50, I'm just drawing them on top of each other. So if I want a little bit more variety, I would add arguments to my functions. If I put an X and Y here, this says now I can move the head to whatever X and Y position I would like to put it in. So instead of numbers, now I'm going to put in X and Y. And I can call these variables anything I want. So now I can draw a head and a face at 50-50. It'll give me that one. And here I can draw another head and a face at 50-150, which will give me the one on the bottom. Now, since I typically want to make that head and face together to make my smiley face, I could even make a smiley face function. So now I got a smiley face function that draws the head and then the face. And then if I want to make a smiley face at 50-50, I only have to type that one line of code. And if I want to make another smiley face at 50-150, right, then I can do it down here. So now I have a pretty high level of abstraction. Just the word smiley face gives me the entire thing, and I don't have to worry about all the details on how those smiley faces were drawn. Now, when you have arguments, you can also use these to do calculations. Here's a simple one. I've made a sum function, and that's going to take two arguments and return their sum, what I get when I add them up. So here I'm going to call it. I'm going to send it 167 and 233. 167 is going to get copied into A. 233 is going to get copied into B. I'm going to add them up, and return means send that back. Imagine scratching this out and putting a 400 here. I'm going to print that 400 to the screen. Well, printing the sum number to the screen is not that interesting. So here I've got a project for you. Actually, a couple two short programs. I want you to copy and paste this into the P5 web editor, and then you're going to come down here to this return 0, and you're going to change it. Instead of returning 0, I want you to write your own code that's going to return the average of the variables A and B. So what's going to happen is right now we draw a line from the center of the screen to wherever the mouse is. What we're going to do is we're going to put an ellipse halfway at the average or the midpoint between where the mouse is and where the center of the screen is. And that ellipse, if we code this average function correctly, will always be stuck right there in the middle of the line. And then I got one more for you. Again, I'm going to ask you to copy and paste this into the P5 web editor, and now you're going to write two functions, a half function and a third function. So this one just has one argument, so you're going to replace the return 0 with the return statement that returns half of num, and in this one you're going to replace return 0 with a statement that returns a third of num. And what we're going to do is we're going to draw the green ellipse halfway to mouse X, but only a third of the way to mouse Y. So when we move it up here, right, you'll see from left to right as we go from 0 to mouse X, the red dot should be halfway to the green dot. But when we come down here, right, you'll see that that red dot only goes about a third of the way down to where mouse Y is. So you got two programs. We're going to write two very quick short functions. Give it a try. Then you're going to want to go to Google Classroom and click Mark as Done to show me you've done this assignment. And then we will talk about our next assignment. Thanks for watching.